So at this point of the course, you should be comfortable using different control structures and stuff like this to actually write some code that is functional. The problem with that is that if you now try to build more and more and more and more of this code, more and more functionality into your programs, then at some point you will have endless, like very long files with a lot of if statements, a lot of for loops, a lot of everything, and they're going to be really hard to read. But don't worry, for that we have functions. So, functions. You could say that functions allow you to function properly within C++. No? Nobody? Okay, I'll show myself out. Okay, but jokes aside, they actually help a lot. They look something like this. So you have some return type, you have a name of your function, you have some input parameters, and then it does something very important inside of it. So all of your logic goes into there, and then you return the value out of the function. We can call this function then from our other code, something like this. We've already seen a bunch of calls to the different functions in the previous lectures without really knowing what a function is. So now you know. Generally speaking, functions split the logic of your program into multiple chunks. And this is very, very helpful. So now if you have this functionality in one place and now you want to change this, you don't have to go over the whole code that you had to change it like everywhere in your code. You actually go into one place and change it there. Now, granted, it takes a little bit of practice to make sure that you can design software that looks like this, that you can actually go into one place and change this one behavior and everything just falls into places. And who am I kidding? It never works ideally this way, but this is the aim, and we can get pretty close to that. Now, one of the main benefits of encapsulating this logic into separate parts of your code is that the code becomes much more readable. If you name your functions right and you use them right, then you can read your code as if it was just a book. And this is the main aim that I always have when I design my software, so that when you open the main file, for example, or the main function, you should be able to just go along, read through it, and it should read like a book. You might have heard already about the DRY principle, which is the don't repeat yourself principle, and it kind of goes along the ways of what I've just talked about. Basically, if you want to change something in your program, there should be one place where you do it. There should never be a couple of places where you have to duplicate your work whenever you need a certain change. There are multiple definitions of this floating around the internet, but this is the way I understand it. And this DRY principle would be impossible to implement in C++ if not for functions. Now, there are some technical details that we have to cover here. So first and foremost, every function creates a scope. So all the variables that live within that scope, they die by the end of that scope. And we will talk about different problems that can come out of this a bit later too. In addition to that, the function is fully defined by its name, its return type, its input types, and then some qualifiers. But we will not talk about qualifiers in this lecture. There is a single return value from every function. You cannot return more than one value, but you can return arbitrarily complex values, so that substitutes for this. But you can return this one value from multiple places in your function. So let's say if you want to return one integer from your function, you can return this one integer at the start of your function, in the middle of your function, or in the end of your function. Depends on what you want to do and depends on the logic that you're building into your function. So every function stops its execution when it reaches the return statement, so it doesn't go beyond that. And if the return type is void, then you don't need an explicit return statement. The function just ends by the end of itself, and it's totally fine to just leave the return statement out. But you can still stop the execution early if you put a return statement somewhere in the front of the function. Let's say if some condition is not met. We'll see more of this later. One of the main things, though, that I want to speak about in this particular lecture is how do you write good functions? Because you can write really bad functions that will be unreadable and unusable, and you will hate yourself when you come back and read them a couple of months afterwards. So the question is, what makes a function a good function? And I would say that the main thing about this is to write short functions. Basically, if the function is short, it does exactly one thing. It doesn't try to do everything in the world. So the functions should really be short. And when I say that they have to do one thing, I mean semantically one thing. Like, for example, it has to print this particular statement, or it has to compute this formula, or it has to update a certain widget or something, right? So that you can say it in one very short phrase what it does. And whenever you want to put an end into your phrase, that means that your function is doing a bit too much, and you should probably split it into multiple ones. The same goes for if your function takes too many parameters. It's also a very good sign that your function is probably trying to be a bit too optimistic about what it can do, and you should probably split it into a couple of ones. There are also a couple of rules of thumb of how to name the functions and stuff like this, and generally speaking, you should name a function as if it was a verb. So update a widget, print the statement, compute the number, right? It all starts with the verb. Because the functions actually do stuff, so it makes sense to name them as if they actually do stuff. You must also clearly state what the function does. So a function that is called func is a horrible name of a function because you will not remember what it does, and when you read the code, the only way to know will be to go and read the code of your function, which is something that you actually want to avoid. On that note, a good name of a function allows you to never actually go and read the code of the function because you trust it to do what you expect it to do. Finally, you should name the functions in a certain consistent manner, and generally I follow the Google style, which suggests to call them in the camel case, and I also name the function arguments with the snake case. But I've seen people doing it differently. Pick one consistent style and stick with it. In this course, we're going to be using the camel case for the name of the function and the snake case for the argument names. Finally, this is a bit of a new feature. It came in C++ 17. Use the nodiscard attribute. An attribute is something that you can put basically anywhere in the code, and there are different attributes. We've seen one before in the control structures that we discussed previously in the switch statement. So this attribute you put before the return type, and that will tell the compiler that you expect this return value to always be used by somebody. So now if you try to write a function and somebody uses this function but doesn't make use of the return type, of the return variable, then the compiler will actually generate a warning for you. And we already talked in the previous lecture that you should always make sure that you have no warnings left in your system after you compile the code. So this is how it looks like if you call this square number. So basically it's a function that squares a number. If you call this function now without assigning its result to any variable, then the compiler will know that you've just discarded this particular variable, and it will tell you that you're doing something wrong because this was marked as no discard. And you can easily circumvent this by actually assigning it to something and actually using it somewhere. Generally speaking, try to use no discard in most of your functions because actually this is the reason for the function to exist, and if it doesn't return a void, then probably you want to do something with the value that it returns. It generally helps avoiding the logical errors that you might do while programming. So let's look at this function example, and I call it a good function example, but it's one of it's good enough. If you don't know what a Fibonacci sequence is, it's a very simple sequence of numbers where basically every next number is a sum of the previous two. So it goes like 1, 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, and so on. Right? So you can always, I will leave a link in the description of what is a Fibonacci sequence if you don't know what that is. But it should be relatively simple. And the reason why I like this function here is it kind of does something complex. It can generate an arbitrary length Fibonacci sequence. It's not the most optimal way to do in this too, but at least the function is very small, it fits on the screen, and it's very readable. To prove that, let's go into this code and actually try to read this function. So the function has a nodiscard attribute. It creates a vector of numbers, and it's called create Fibonacci sequence, which leaves no room for questions, I hope. And then you provide it with the lengths of how long the sequence do you want. You create a vector that basically of a certain length and filled with ones, because the 1 is where we start. And if its length is less than 3, then we can return it easily straight away, because the Fibonacci sequence until length 3 is always consists of ones. And then if it's not, if it's longer than 3, then we start from the second element of the Fibonacci sequence and we start computing them going forward, just the way I described before. So you see that the function is actually quite easy to read, and this is what you should aim for. It does exactly one thing, it has a good name, and it follows all of the procedures that we discussed before. Now, if we look at the bad function example, I want to actually let you read this code for a bit. So pause this video, take some time, try to understand what this function does. Go ahead, really do it. Okay? And you probably had troubles, right? And this is not a big function, right? So it's a bad function, but it's not the worst that I've seen. The worst the functions that you work with are the huge functions that have a very bad name, that have very bad variable names in them, and that are impossible to read. So here it's hard to understand what it does at a glance, and the reason for this is because it's named badly, it takes really weird parameters, and then the variables inside of it also mean nothing. And then it also doesn't have a single purpose. It does a couple of things that are not really related to each other. So it's really hard to even name this function at this point, which means that it probably should not be a function at all, and it should be split into multiple ones that would have proper names. I hope it explains what I want to convey here, that every function should be like a good function, right? Have a good name, do one thing, yada yada yada. Okay, the functions can be declared and defined just like variables can. We've already touched upon that before, but here basically you have options to first do the function declaration, which is then separated from the implementation details. And the cool part about this is that the implementation details can even be hidden from the user, but we will talk about this a bit later when we talk about how to create libraries and things like that. So the way it works is you first write a function. Let's say we have this func name. It's a horrible name, but I just wanted to show a function here, and it really doesn't do anything important. So the way you declare the function, you end its declaration with the semicolon, and when you define the function, then you actually have to open the curly brackets and put in the logic that you want in the function. Now beware that the return type and the name of the function and the input parameter have to be exactly the same, and we will discuss in a couple of slides why that matters. One of the most important things that you see, especially beginners, do wrong is treating big objects when we pass them into functions. This is one of those things in C++ that is not very beginner friendly, but once you understand this, it's not really hard. Generally speaking, in C++, every object that you pass somewhere is copied by default. So if you don't provide anything, if you don't do any additional actions, it will be copied into some other place, which is totally fine for very small objects, the ones of fundamental types, generally speaking. But it's not really that good if the objects are bigger, because then you copy a lot of memory, and copying memory takes a lot of time. So you want to pass the big objects by reference to avoid copying. We already discussed references before, and I hinted on this use for the references, but now we actually get to see this. So here are 3 small examples. So if you do something small, then you can just pass it by without providing anything additional, and then this number, the float number, will be just copied. If you do something big, then with a huge string and you don't use a reference, this is not really good because this string will be copied over. But if you want to make sure that it's not copied, then you just put a reference there. Mind that it's still not the best, and we will discuss on the next slide what can be the problem with this. So let's talk a little bit about this. What is the difference between passing by value and passing by reference? So whenever, this is an example that I really, really like, and thank you to whoever did this, because it explains the concept so well. So let's say you have this cup, and then you pass this cup into a fill function or a fill cup function. I will use a fill name here for my functions. because they just don't, otherwise they don't fit on the slide. So you want to fill this cup. Now, what do? If you pass this cup by reference, then whatever happens inside of the function fill will actually fill the actual cup that we have. Because whatever we do with the reference happens to the object to which the reference is bound. So, but if we pass it by value, then we only change the copy of that object, of our cup. So the copy of the cup will be filled, but our cup that we wanted to fill is not. So this is assuming that we actually want our object to change. But it's not really what we want all the time. Do you see any problems with passing a reference there? Let's look at this small example. So let's say we have this function, do something with reference, and we pass this string, which can be a big string by reference, and now we call it from somewhere in the code. So we call this do something with reference, and we give this hello. Is hello the same? Does hello have the same value? And the issue with that is that it's largely unknown. We really don't know if it is the case. We will only know this after we look into the code of the function, which also might not even be available to us if it's written as a library and hidden away from us. So it's really not a very nice place to be, because now your users have to wonder, hey, can I use this function at all? What if I want to guarantee that my variable doesn't change when I call this particular function? And the solution to this problem is actually quite simple. You just use const. As I told you before, you should always use const if you can use const. This is exactly the same here. If you can use const, which you mostly should be able to, then do that. So for all the big objects, just pass them by the const reference. The benefits of this are quite easy to explain. It's still going to be as fast as passing the normal reference because it's still a reference, but then the object is guaranteed to stay intact because it is a constant reference, so we cannot change the object under this reference. Historically, in a lot of code that you will encounter when you work with C++, you will see a lot of places where people actually pass the normal reference and not a const reference. And in most of those places, this is some artifact from older C++ times. Because before C++ 11, it would actually take some time to return a certain object from, like a big object from a function. But it's not the case anymore. So in C++ 11 and up, this is mostly always fast. But in C++ 17, this is guaranteed to be fast. So generally, if you follow, say, Google-style recommendations, then you should not be using non-const references with your functions, and you should always be using const references. Sometimes, in very rare cases, it is faster to actually change the variable that you pass by reference, but then you explicitly really want this particular input argument or input-output argument to change. But you really have to measure before you do this. It's not always faster, and sometimes it's actually even slower in modern C++. So don't believe anybody who tells you that this is the faster way. Try to measure and convince them otherwise. Okay, one of the pitfalls because of the scope of a function is that everything that you create within a function will die within a function. And that means that if you try to, say, return a reference to a local object, to a function local object, then this object will not exist when you actually need it. So you will end up with undefined behavior again. So for example, this would look like this. If you have a function that returns a reference, then you create a local variable and you return this local variable. So you return a reference to this local variable. Then whoever gets it will get garbage because this local variable will not exist anymore at the point where somebody else gets this reference. And this is horrible, and that's why most of the modern compilers actually implement a check for this, and they will tell you. So they will warn you that something is off and you are trying to return a function local object to the outside of this function. So we should be relatively safe here, but please, please, please always get rid of all your warnings whenever you compile your code. The other topic that we need to cover when we talk about functions is so-called function overloading. And this is why it's important to make sure that you're always having exactly the same types whenever you do the definition and declaration of your functions, because if you don't match them perfectly, then the functions will actually be overloaded rather than just declared and defined. Let's look at this small example here, and I think it should explain it pretty well. So you have a number of functions that have exactly the same name, but have different parameters. And then the compiler will pick the proper function to use, even though all of them have the same name, looking at the parameters. So let's say we have this getNames functions. One of them takes an integer, one of them takes the string or the const string reference, and one of them takes the number, like two numbers, int and a float. And then when you call them with different set of parameters, the different ones will run. And feel free to copy this code over and actually run it on your own so that you get a little bit of more experience with this and the feeling for it. Now you have to be mindful to actually make sure that all of your overloads do semantically the same thing. So here we have this getNames, it always gets the names of whatever we pass into it, right? But if it would do something a little bit different, then it would not be a good place to have an overload, and then it should be a different function with a different name. I hope it makes sense. Again, it kind of reflects back on the functions that should have a very good name and should tell exactly what they're doing. So if you follow that rule, then this one you will automatically follow too. One final thing to cover with the functions is the default arguments. It might seem like a good idea to be able to set certain arguments to a default state. So for example, if you have this function do something and it takes a number, let's set it by default to 42. It's kind of hard to explain without looking at big examples, but in my own experience, it's much nicer to always provide the parameters into every function explicitly, because that makes sure that you have less errors in your code in the long run. Generally speaking, whenever you have any hidden state in your program, that's where all of the bugs will be hiding, because it's a hidden state, right? So this is one of those. Like if you set somewhere in your code this parameter to be a default value, you will definitely forget about this. And then at some point you will sit and wonder, why does the program does what it does, without remembering that it does so because you set this default value. This would not happen if you provide explicit parameters. It takes a little bit more typing, but typing is not a problem. You should set up your text editor so that it helps you, but other than that, just probably avoid this most of the times unless it really improves the readability. And to be honest, in my experience, it's very rare. But just for completeness, let's look at this small example here. Let's say we have this say hello function that basically just returns a string of saying hello to whatever it says hello to. And let's say that by default, to whom is actually set to be in world. So we can call it without the parameters and it will say hello world. But if we call it with the parameter students, it will say hello to students. And that's kind of it. So again, feel free to play around with this code. All the code is available, again, as always, in the link in the description of this video. But that should be that. So, and now after this lecture, you should feel quite comfortable writing simple functions in your code. And going forward, we will look at how they enable writing much more complex software that we've done before. See you in the next one. Bye.